Hello, this is Math 2134 coming to you from the College of DuPage during the fall of 2020, and the title of this lecture is Functions, Domains, Ranges, and Such. A function is a rule that assigns to each element in a set A one and only one element in a set B. It can be thought of as a machine where the input is x, the machine is the function, and the output is f of x. The set of allowable values, the allowable inputs for x is called the domain, and the values that you can get out of the machine are called the range. Again, we should emphasize that the output for an input x is unique, and in our textbook, sets A and B will always be sets of real numbers. So here's an example. What we want to do is practice putting things into the machine and getting things out. You know what to do. Let's see how you did. Well, you should have gotten 2, 11n, 2a squared minus a plus 1. You have to simplify this. The one that's most interesting is when the input is a plus h, you're going to substitute everywhere that you find an x, you're going to substitute a plus h. So it's going to be 2a plus h whole squared minus parentheses a plus h plus 1. You have to simplify that by squaring this, distributing the 2, distributing the minus sign, and at the end of that you will get this as your answer. We will be doing this quite a bit as we go on, so make sure you understand that one for sure. Life is a word problem, and so we are going to be working with word problems, particularly in this class. So here's one for you to read and do. You know what to do. Let's see how you did. So when you take this function, you're going to plug in 1,000 and 2,000, and you'll get 7,000 as the answer to B and 2,000 for the answer to A. So suppose we were given a function y equals f of x. X, the inputs are called the independent variable because you get to pick what you put into the machine as long as it makes sense as an output. The variable y, whose value depends on x, is called the dependent variable. To determine the domain of a function, we need to find out what restrictions, if any, are placed on the independent variable so the output makes sense. In many practical problems, the domain of a function is dictated by the nature of the problem and the geometry of the problem as indicated in the next example. So please read this example and you know what to do. You want to find the domain. You want to do two things. Find an expression that gives you the volume as a function of x and determine what is the domain. You know what to do. Let's see how you did. So if you draw the picture, you have a rectangular sheet. You're cutting squares of size x out of each corner, and you're folding it up to make a box. So this side used to be 10, but now it is going to be 10 minus 2x because you take x from both sides. This used to be 16, but you're taking x from both sides, so that is 16 minus 2x, and when you fold it up, you have x is the depth, that is one side, and that is the other. So the volume is length times width times height, so it is the product of these, and when you simplify it you get this expression. So that is the answer to the first part. Since the length of each side of the box must be greater than or equal to 0, this must be greater than or equal to 0, x must be greater than or equal to 0, and this side must be greater than or equal to 0. And actually it needs to be greater than 0 to really have a box. So that means the domain is going to be between 0 and 5 because 5 is smaller than 8. Make sure you understand this example. In general, if a function is defined by a rule relating x to f of x without mentioning its domain, it is understood that the domain will consist of all values of x for which f of x is a real number. In this connection, you should keep in mind that division by 0 is not permitted, and the even root of a negative number is not a real number, so it must be discarded as well. So here's a problem where you have representations for y equals f of x. You want to find the domain of each function. You know what to do. Let's see how you did. So here, since you cannot take the square root of a negative number, this must be greater than or equal to 1, and that is the domain for part A. Here you can't have a 0 on the denominator, so we have to skip the values of plus or minus 2. That means the domain of f, in that case, consists of the intervals from minus infinity to minus 2, not counting minus 2, minus 2 to 2, not counting either endpoint, and from 2 to infinity, again, not counting the 2. Here, there's no problem, there's no denominator, there's no square roots, and that means any real number satisfied. So the domain is all real numbers, or from minus infinity to positive infinity. We're going to continue this in 5.1.